Use the side angle side similarity theorem to see whether or not these two triangles are similar, and if they are, then we'll write a similarity statement. Remember, the side angle side theorem says that if we are looking at the side and the angle and the side of one triangle and comparing it to the corresponding side, angle, and side of another triangle, the angles have to be the same, and it looks like in these triangles they are, right? The angle that we're going to use is that right angle. And then the sides that are coming off that angle have to be, the ratios of those corresponding sides have to be the same. Okay, so the first thing is to look at the angle, and yes, we've already talked about this. Those two angles are the same measurement. They're both 90 degrees. So now it's just a matter of looking at the corresponding side. So I'm going to match up one of these sides with one of these sides, the other one over here with another one over here. We've just got to make sure we're matching up the right sides. And don't get too confused with this. I've got a large side and a small side. If these triangles are going to be the similar triangles, I should have them corresponding. You know, large one here goes with the large one here. The smaller one here goes with the smaller one here. So that's what I'm going to do. 15, the side coming off that right angle in the large triangle, should correspond with 10, which is the large side coming off the right angle in the smaller triangle. It goes together as a ratio in the same way as the smaller side here goes with the smaller side here. So if these two ratios are the same, and we already know the angles are the same, then we can say these triangles are similar. Well, 15/10 is the same as 3/2, and 9/6 is the same as 3/2. So we do have sides that are the same ratio, they're proportionate, and they're coming off of an angle. So we can say by the side angle side similarity theorem that these triangles are indeed similar. So let's write a similarity statement. One triangle is similar to another triangle. If I call this one EDF, I need to call this triangle something. It might be XYW or WYX or WXY. I just got to make sure it matches up with E and D and F in that order. Now E is the angle on the other side of that small side. Okay, 9 matched up with 6. So we're talking about this side matching up with this side, not the right angle, but the other one that's coming off of it. So Y is the point that matches up with E. D is next to our right angle, so that's easy to find over here. That's W. And then the remaining one, F, must match up with X. So there's my similarity statement of the two triangles that are similar. Now, not all the time you're going to find the triangles that are similar. So what could have happened, let's say this was something like 8 instead of 9. And now over here we would have had not 9/6 but 8/6, which is not 3/2. At that point, we would have had to have said that these triangles aren't similar because the ratios aren't the same. Even though it would be close, they wouldn't have been exactly the same ratio, so the triangles aren't similar. Thankfully, this one was 9, so the ratios were similar, or equal, so the triangles are similar.